So let's look at the following piecewise defined function. Now let's revisit the meaning of these statements. Recall from previous years of math class that the absolute value of x being less than 1. This essentially leads to the following statement. X being less than 1, x being greater than -1. It's what we call a conjunction. And we can get into the theory behind this, but this is essentially the same as that. Also, similarly, the absolute value of x being greater than or equal to 1, this leads to two statements. X is greater than 1, or x is less than -1. So again, we won't get into this, but this is just the conclusions. This is the same as that, and this is the same as that. So over here, when it says that this function looks like that during this, I'm basically just going to ignore this and pretend that it says that instead. I'm going to ignore this and just pretend that it says this instead. This really is easier for my brain to process. Now, if I go to the x and y axis, and if I pay attention to, let's call that -1, and let's call this 1. So I look like that in this window, meaning everything between my hands here in this empty space. And then I look like this, both here and there. So let's graph this piece first. So I know that I look like this. By the way, that's just x. We know for sure that the graph of x is literally just a line that runs at a 45-degree angle. Now, when do I look like this? During this time and during this time. So x greater than 1. If I plug in 1 into here, it's literally 1. So it's 1, 1. But if I go to 1, 1, it has to be a whole because there's no equality. Actually, I take it back. That should have had equality here and there and there and there. Ha ha ha. So this is actually a closed circle, right? It's a closed circle. Similarly, how about this one here? If I plug -1 in for x, there, I get back -1 for y. So I get back -1, -1. So that's closed. And I know that it essentially looks like this, right? It essentially looks like that. It's a portion of that line y equals x, but it's not all of it. It's only from here like that. Because all the space in the middle, we look like this. But now the question is, what does this look like? Well, let's see. Let's use these points. Plug in 1 into there. That becomes the tangent of pi over 4, which is going to be 1. So it's 1, 1. So it's right here. And then plug in -1 in there on your calculator if you want. And you're going to see that it's the tangent of -pi over 4, which you're going to see is -1, which is right there. So that would actually be an open circle. And this would also be an open circle, right? These are open, but it looks closed because there was already a solid point there given to us from this piece. So now, what does all this look like here? Well, what if I plug in a point that's between -1 and 1? How about 0? If I plug 0 in for x there, it's the tangent of 0, which is 0. And now for the rest of it, you would actually have to make a table of values, something like x versus tangent of pi x over 4. And the numbers that I would use, I would not use the -1, 1, or the 0. We already did that. I'd use like -1/2. I'd use like +1/2. So if you pick enough x values here for this column and plug them in here, you're going to get a lot of strange decimals. But if you plot all of those points, you're going to see that the graph actually ends up looking something like this. It ends up looking something like that. So was it necessary to make a graph and a table? No, I think it helped. But I think what was really necessary and helpful was instead of writing this to write that, instead of writing this to write that, because then we know what to do. We plug in 1 into there to see what the y coordinate is. You plug in 1 into there to see if it's the same y coordinate. And if it's the same y coordinate, then they are continuous, right? They overlap, so it's continuous. Take -1, plug it in there to see the y. Take -1, plug it in there to see the y. If their y coordinates match, then it is continuous at that location. So the graph and the table was just extra. but I think this to that really came in clutch.